Thank you, Michaela, and welcome to today's webinar on Belimo's new Energy Valve Data Analysis Tool. This webinar is an overview of the tool, which will cover the basics of the tool, system requirements, and a look at each tab and its functionality. Please know that this is not a detailed breakdown or an analysis of the tool, but a general overview of the tool's capabilities and analytics. More in-depth webinars will be available in the near future. So, let's get started. Overview. What is the Energy Valve Analysis Tool? Well, the data analysis tool is to be used in conjunction with the Energy Valve itself to provide analysis of the stored data, deliver efficiency and cost savings for your system. The tool can seamlessly import up to 13 months of trended data stored inside the valve, along with performance metrics of the system, which all can be viewed, emailed, or printed graphically. You can get the most out of the Energy Valve Data Analysis Tool by viewing potential pumping saving using the Delta T Manager and optimizing the correct Delta T set point based upon coil operating conditions. And that's what we're going to take a look at today. Basic compatibility and system requirements. You need to run Windows 10, 8.18, or Windows 7 with Service Pack 1. As it says, for the best experience, always make sure you're running the latest version of any operating system and are up to date on their service packs and patches. It'll run on Excel 2007 through 2016. We highly recommend at least a 1 gigahertz processor or faster, 2 gigabytes RAM or better, the more the better in this case, 3 gigabytes of disk space, and at least a 1280 by 800 or better screen resolution. They're also, for graphic hardware acceleration, we do require direct 10x graphics card or better. But that's available on most laptops today, so that shouldn't be of any issues or problems. The first screen that comes up is the dashboard screen. This is a general overview of the Energy Valve and basically what's going on. So let's take a look at what this screen has entailed. The top of it is basically your selection buttons. This allows you to navigate through the different basic tabs of the Energy Valve so that you can look at different types of analysis like it shows on top. Valve analysis, Delta T analysis, Delta T determination, and the cost calculator. The next thing we have is the Import Data button. This is where you would actually go out to find the stored data on your current hard drive that you would like to pull in and do your data analysis on. Once you pull in that data, the data range box right here will show you what the range of data is that you pulled in. On the select graph range, you actually have the ability, there are 2 drop-down boxes here that you can select from and to starting and ending positions. This allows you to narrow or zoom in, if you will, onto very specific parts of data that you might want to take a look at. The next box down is a little quick link to do the same thing. You can go in and simply say, hey, I would like to look at 1 day of data or 2 days of data, etc. Or I could click on just give me 10 minutes or an hour, 6 hours, a day, 7 days, or this one here would give you the full time period that you had imported into the tool. The next one allows you to select which plots you would like to see on your graphical analysis up here. On the top is your power and control, and on the bottom is temperature and Delta T limiting. So simply by clicking on the different values, for instance, relative flow, absolute flow, power, DDC set point, cooling or energy or Delta T manager, you will select the graph right here that'll show over the time period that you have selected exactly what the valve is doing. You then also have the ability to advance either forward or backwards based upon these time limiters through the screens to go forward in time and backwards in time to see what the valve is doing. The next thing we have is over on the right-hand side, you have 3 buttons on the top. The first one is the ability to email a copy of the screen to someone. So if you've done a little analysis and you saw something that didn't look right or was out of sequence, you could email a shot of this screen to anybody. You could also print a copy of this screen out on your printer. Or you have the I right here, which gives you the version information and system requirements that the tool needs. Upon importing data, you will get a pop-up screen that asks you to put in the customer name or the job name of the particular data set that you have. It'll also ask you for an air handler unit name or a heat exchanger. These are two values that you can put in whatever you would like it to be so that you remember what it is that you're working on. It'll pull the valve size, saying how many gallons per minute it is and what size valve it is. It'll also show you the valve settings, and notice it says errors. This is where all the information is imported on what the units of measure are, whether they're US or metric. And if anything, any one of these measurements changes throughout your data set, for instance, let's say that maybe it was originally set up at degrees Fahrenheit, but then someone switched it over to Celsius, you would get an error message right here telling you the date and time that it was changed and what it was changed to, because now that data has actually become corrupted because you have two different units of measuring which will not calculate properly. Next one is your time zone. You have the ability to set the time zone for the data set that you're importing. So if you're importing a data set from the West Coast and you're in the East Coast, you can change the timestamp to match so that your times align. The next tab is called the Valve Analysis tab. Again, we start off with the dashboard on the top of the screen, which allows you to easily navigate between the different tabs. We display that customer name, air handler unit number, and flow rates for the valve so that you have in front of you exactly what it is that you're working with. We also then put the valve settings in, as you can see here. The valve is a 317 gallon per minute valve, and it's set at 90% of its flow, so its rated flow is 285 gallons per minute. It's installed on the return, the temperature is in degrees Fahrenheit, and the flow is in gallons per minute. The next box is the time frame. We display this so that you remember what you selected on the dashboard screen. So for instance, if on the dashboard screen you imported 31 days of data, but then you only wanted, and you selected down to 1 day, all of your calculations throughout the tool will be 1 day. So here is where we're showing you what it was that you're selected so that you don't think that, hey, I was looking at 31 days. Well, I'm only looking at 1 day. That's why we put that there. The next box is the control mode. As you probably are aware of, the valve operates in 3 different control modes. And this is going to tell you how many minutes by mode the valve is operating. So as you can see in this scenario, that this valve was in flow control for 1,440 minutes, which is 100% of the time the valve is operating in this time frame. The next thing is override mode. Again, it's in the 3 different types of controls. But what this tells you is it allows you to take a look at how many minutes that maybe someone logged into the valve and overrode the control. You can go inside the valve through WebView, as many of you may know, and you can take control. You can open the valve, you can close the valve, you can stop the valve, you can change the set points so that you can see different things. So if you're actually going in and overriding the valve, that will change your data set, and that's something that you need to be aware of, and hence that's why that's on the screen. Flow set point percent in minutes, we also do that by type of control. So if you were operating in the 3 different controls trying to compare data, this particular one would tell you by control mode what percentage of where the set point was in minutes. And as you can see, for the entire time of 1,440 minutes, the DDC control signal was 75 to 100% open. The next position down is relative valve position in minutes, again by the 3 different modes. And this is just telling you what position the valve is in during the period of time of the data set. So for 521 minutes, we were between 25 and 50%, and for 919 minutes, we were between 50 and 75%. Now you may be wondering out there, how come my DDC control signal is saying that I'm 75 to 100% for the entire time period, but when we actually look at the actual valve position below, we see that we're only running between 25 and 75%. Well, there's a couple of reasons for that, and that's what the more advanced classes will get into, but I can just throw you a little hint that it could be a couple different things. One, as we mentioned up here, the valve Vmax was reduced from the total of 317 down to 285. And another thing might be that Delta T Manager might be active right now and taking control of the flow, not allowing it to overflow. The next screen in the valve canals, we continue on. Flow gallons by relative valve position. So what we're going to say now, in that 25 to 50% we looked at a minute ago, what was the flow in gallons that went through the valve at that time period? The one below it is the average flow for the same type of calculation. So as you can see, when the valve was between 25 and 50% open, we were averaging 103 gallons per minute. Flow in GPM is overall. We show the maximum GPM the valve flowed, the average it flowed, and what the total amount of water was that flowed through the valve during that time period. But notice over here we've got a little drop-down box to include zero flow or do not include zero flow. The reason you'd want to use do not include zero flow is for instances and scenarios where, let's say, every single night at 11 o'clock the air handler shuts down and goes to off mode, and then in the morning at 6 a.m. it fires back up. Well, if you include that zero flow for the entire night, it's going to throw your averages off. So if you want to know truly what the average amount of water that was flowing through the valve, you would not include zero flow. But it gives you the option to look both ways. The next box down is the temperature 1 unit, which could either be the supply or the return, depending upon what position the valve was installed, which was on your front dashboard screen. It showed you where the valve was installed. Notice, as it says, the note on the bottom, units of measure are displayed via valve settings. So when you see GPM or degrees F or kBTUs, based upon the valve settings on the dashboard, that's what you would see here. So if we were set to Celsius, it would say temp 1 degrees C. But this is telling you what the minimum, the maximum average T1 temperature is. And on the T2, it tells you what the minimum, maximum, and average temperature is. You can see here pretty much we're averaging what, about a 12-degree delta T, right? Pretty much across the boards we're running 12 degrees, which is pretty good. Then you also have the same thing, min, max, and average when it comes to power or BTU output of that coil. The next tab is the delta T analysis tab. Now this is where it gets fun. This is when we start to actually start taking a look at what's going on in our system. Again, we start with the dashboard, which allows us to navigate. We remind ourselves of the customer, what the air handling unit was and what the size is. We're looking at the valve settings, the time frame of data that we're looking at. And then what we have down here is the delta T limiting value. By control mode, this is going to actually show you, based upon different delta T's, what's going on in your system. So if there was a little drop-down box right here that you could click on, you would click on the drop-down box, and let's say we ran it at 10 degrees, and then we ran it at 12 degrees, and we ran it at 14 degrees. This will allow you to do all, see what's going on in the valve for the entire period of time, or you can actually see what's going on in the valve by the different delta T limiting values. For instance, if I clicked on 10, it would give me all the information below what happened in the system at 10 degrees. And if I did 12 or 14, same thing. An interesting note is if you do run in more than one delta T mode, what you will actually get is another box over here on the right-hand side of your screen, which will duplicate this. So that allows you to actually compare side to side, 10 degrees to 12 degrees, for instance. Very handy when you're doing data analysis. The next box down is delta T mode. This is going to tell you how many minutes that the delta T manager was turned on or off. For instance, for that entire one-day period of time, the delta T manager was always turned on, ready to be used if needed. The next one is how many minutes it was active. And as you can see in this particular scenario, it was turned on for 1,440 minutes, but it was always active. It means in this particular data set, for this one-day period of time, the delta T manager was in control of the valve for the entire time period. The next one down is just a graphical representative of that picture, and as you can see, we have a 100% pie graph in the flow control mode because, as we said before, the unit was actually active the entire time. Next box down is a nice, interesting little box, and it's good to note here that anything that you see in orange allows you to input. This just allows you, by control mode, to play around with how many minutes the valve was in based upon different temperature delta T's. So I could go in here and I could put 10 degrees and it'll tell me how many minutes I was above or below 10 degrees. It's just something to take a look at and play around with a little bit to see where the valve is kind of running. Delta degrees in Fahrenheit in this case is by control mode again, because you can run the valve in the 3 different modes. It's going to tell you what the minimum, the average, and maximum delta T was. As we saw on another screen, yeah, we're averaging around 12 degrees. And as we noted before, the delta T manager was set at 12 degrees, and as this is showing, we're holding it at 12 degrees. Again, down below, and you can see over here, we can also include or do not include zero flow, which is very important for those times when we're not active. The next box down is delta T manager flow in gallons per minute, and what this is showing you, in this case, remember, we were always 100% on. We were never in standby. So in this case, when the delta T manager was activated, we were averaging 110 gallons per minute, and during that time that we were active, we flowed this much water. So if I was running between I was on and I was off, this box would be populated of what the average GPM was when the delta T manager wasn't active and how many gallons I flowed at that point in time. This is a very interesting box. This shows you what happens when the delta T manager is activated. So in other words, every time the delta T manager was turned on or became active, we take a time stamp in that point in time. And then we take an average of all those stamps. So in this case, it's saying that the average flow rate through the valve when the delta T manager activated itself, took control of the valve, was at 120.24 GPM. The delta T when it was turning on was 10.11 degrees. So that's part of that little deadband that's in the valve to compensate for hysteresis. And the average kBTU at that time when it was actually activating was 466.23 BTUs. What does this tell you? Why is it interesting? We get into that a lot more in the advanced webinars we'll be talking about, but I can tell you right now, pretty much what this is saying is at 120.24 GPM, that coil is done. In other words, it doesn't have any more ability to produce any more power at 10 degrees delta T and 120 gallons per minute. The next tab is the Power Analysis tab. And again, we start with the Navigations button. But in this case, you have the ability, because this is a Power Analysis graph that's going to determine what the capabilities of your coil is. You could, from here, instead of going back to the dashboard, we could import a different data set, or we could change the date range, or anything that we wanted to. From there, we would then calculate, all right, which is going to generate these curves. In this example, this is showing us that pretty much, like you can see up here, here's your curve right here. Here's your power curve, this red line right here. And you can see it right around, 8 degrees delta and what? About 84, 85 gallons of water were maxed out on coil BTU output. So all of this out here, as we're increasing our flow in GPM, is not giving us any more output in BTUs. This is what we call the saturation point. The next and the last tab in calculating anyway is the cost calculation tab. Again, we start with the dashboard so that we can quickly and easily go between tabs. The next part is what's called the waste zone calculator. What we're doing here is we're actually taking a look at the projected flow rate of the water through the valve when the delta T manager was active. So in other words, we look at what the DDC control signal is when the delta T manager activates itself or takes control. We then calculate what the flow would have been through the valve at that DDC set point. So as you can see here, the projected flow rate, if the DDC was in charge, would have been 277 GPM. What we actually flowed, because the delta T manager was invoked or active, was 110. So we had a total projected gallons of 335,000. We actually only flowed 158. So we had a 60% savings in pumping. So that's the waste zone calculator. That is what we would have pumped if we were not in control with the delta T manager. The next box down is actual water pump cost comparison to the delta T manager by a standby and active. And what we're doing here, and these little icons with the little eye right here, is just going to pop up a box telling you that all we are doing is using very simple pump affinity laws to calculate these values. So we're pretty much by the different modes, and this will only work in flow control right now. We're taking a look at the total amount of hours, the flow rate that went through the valve, what the average is, what head and feet, which you would have inputted up here. Customer input, you're going to put in your utility costs, your pumping efficiency, and your head and feet. And we're going to take those values down here, and we're going to calculate what it actually costs to pump water through that valve for the time period selected. Then what we do is we take a look at that same thing in standby mode. In other words, what was going on to the valve when the Delta T manager wasn't active, and as we already know, it was active the whole time, so these boxes are blank. And then what it actually was in cost when the Delta T manager was in active mode. So you're getting a cost analysis of what's going on the valve in the different modes. On the bottom here is our projected pump water costs. And basically all we're doing is we're taking the information up here on the top that we looked up here, and we're calculating what the value would have been if you were not in that mode. The next thing we do is we have to take a look at the savings calculator, and pretty much all we're doing is looking at pumping costs, what it was in standby, which, as we know, we were always involved, our total projected pumping costs, and we subtract out what the actual was. It's going to give us a savings per time period and an annual savings based upon those values. And then down here we have a return on investment, which is just pretty much going to take the values that you put up in here for the cost of the valve and the installation over what the run, and this is what the payback would be in years. Again, using simple formulas, nothing, no bells and whistles, no smoke and mirrors, just basic pump affinity laws. So that's the cost calculation page. There's a couple of more tabs that make your life a little easier. This one is called the network data file import. For those of you that are familiar with the valve, which I hope you are, typically what you used to have to do would be to go to the valve, plug in your laptop, bring up WebView, and then manually download all those data files one at a time. Well, you can do this with the actual data analysis tool on this screen. We start out again with the dashboard, of course, and then what we have down here is you have the ability to say whether you would like to retrieve the day files on the valve or the month files on the valve. So you're just going to click in whether you want the days or the month. You're then going to put in the IP address of the energy valve. So now this means what you can do is you can either plug directly into the valve like you had to do before and put in the IP address of the valve, or if you're on an internal LAN or an IP subnet, and you can just plug your laptop anywhere in on that LAN, and you could do the same thing. You don't have to physically go to the valve anymore to get that information. All you need to do is put in the IP address of the valve, give it a name right here, and click the connection button, and it's going to tell you whether you have a link to the valve or not. So hopefully this will say online, you have a link. It's also going to tell you what your personal computer address. Now, of course, this needs to agree. The subnet inside here has to be the same for you to talk to it. It's also going to tell you what the name of your laptop is. This is the Get Data Files button. What this does is it just jumps out to the internet quick and grabs a little file that creates a folder structure on your local hard drive. It doesn't install any software whatsoever. All it does is create a folder structure on your hard drive. So when you download these data files, they're going to go directly to that folder. In the future, this would be something that you would be able to define and put it anywhere you want. But for this version of the tool, we had to hard code it to go to a very specific place. Once you've done that, you're going to click on the download button, and pretty much it's going to go out to the valve. And if you're in the day mode, it's going to automatically download and import into the tool the last 31 days of data. So what this does, instead of you having to go to the dashboard, click on import, go get all the files, you can do it right from here. You can just click on download, it'll go out to the valve, it'll get the last 31 days and import it into the data analysis tool, and then you can work on it. The next one is called the network data file download page. This is about the same but a little different. We start out with the header tabs for your navigation, and we have the same thing. You can select whether you want day file or month files. This is an output valve. As you can see, it says number 1, based upon the information you put here. You can put up to 10 separate valves currently on this sheet. So again, if I'm connected to that internal LAN, And I could put up to 10 IP addresses and unit IDs of valves right here that are on my system. I would check them to see if they're all online. And once I know they're all online, all I have to do is, after I verify my address, is click the down data files. And what that'll do is it'll go out to those 10 valves, and it'll download to a folder on your computer for you to use later, the daily or the monthly data files automatically for you. You do not have to do it manually going to the valve anymore. There is also an automated version of this that uses simple scripting routine that will actually just use Microsoft Scheduler to every single day or every single week or whatever you'd like, automatically go to your valves and get that data for you, so you don't even have to do this exercise. Where do I download the tool? Well, the tool will be fully available for download in September of 2016. You'll be able to get it at energyvalve.com and just go to the Resources, Tool, and Download It Now tab. If you would like to use the beta version of this tool, which is out, all you need to do is contact your district sales manager, and you can do that by going to belimo.us and then select Contact Us. You'll be able to link in by what state you're in, and it'll give you the details of who your district manager is, and just please feel free to contact that manager and ask to get a copy of the beta test, and they'd be happy to send it to you. I would love your feedback and input if you do want to use the beta tool. We're constantly improving it, and we've got a lot of great ideas for it, but I can always use more input. Okay, I guess that brings us to the end of the seminar, and that opens it up for questions. Michaela.
Thank you so much, Rick. So while all of you are just absorbing the information and typing in those questions, just want to remind you that this webinar has been recorded and will be released and posted to various Belimo websites. Also, if you're interested, we do have a PDF of the presentation in the handout section of your GoToWebinar screen. Okay, so if you do have any questions, feel free to type them in. I will read them aloud, and Rick will answer them as best as possible. Are you ready, Rick?
Sure.
Okay, the first question is the analysis tool supported on a server 2012 operating system?
Yes.
Yes. Okay, great. Where are these energy valves most used? In which situations do you see the most cost savings?
That's a hard question to answer on the surface. Pretty much in any air handler unit, exchange, heat exchanger, etc., where you are experiencing low delta T syndrome, that's where you would want to use them. There's two basic operations. One is to control delta T and increase coil efficiency. The other is data acquisition and the ability to document exactly what the valve is doing. So I guess you'd have to look into those two scenarios.
Okay. Is there a way to zero calibrate the flow sensor via WebView?
There's no need to zero calibrate the flow sensors at any point in time. They are factory calibrated from Belimo's factory. They are all wet tested, and there are no adjustments to be made to them in the field ever.
Okay. Next question. Is the beta version sent by mail or a link or a CD?
It could be sent by email, depending upon whether or not your email server may or may reject VB scripted encoded Excel. It can also be put on for file download from our website if need be.
Okay. Can you get all of this info through BACnet to automation instead of using the software?
Yes, you can. The valve is fully BACnet integrated. You can pull a variety of 38 to 40 different data points via BACnet and do all the trending yourself. You can also, we have BACnet trending that dumps to a .csv file, so you can actually do your own trending, and you can also dump it to a CSV file and then import it into the tool.
Okay, a couple more questions. Does the analysis tool log errors such as clutch, engaged, or too many air bubbles?
Yes, it does. That's in the next release of the tool. There will be a diagnostics page. Right now, to see those diagnostics, you would have to log into the valve with WebView, and there is a diags tab inside WebView that will give you the count and the errors that are going on. Flow not realized, which is probably one of the bigger ones. Air bubbles is definitely one of them. But the next release of the tool will have diagnostics built into it, so you don't have to physically connect to the valve.
So it's not built in the beta version right now?
Not in the beta version.
Okay. If the IP address is changed in the field, will the tool automatically adapt to that change?
No, it has to know it's a static IP, so you'd have to put the IP address into the network download or import screens.
Okay. And one last question. With the data download, do we have to go to the job site and link the local LAN? Is there any possibility or future intention to be able to connect wirelessly?
You can do that now. There are different types of way to do it. We do it in some more secure hospitals where I need to collect data. We'll actually use a wireless gateway. So yes, that is totally doable.
Wonderful. Well, thank you so much, Rick, and thank you to everyone for attending the webinar. If at a later time you have a question for Rick or a question for myself, feel free to email us at marketing@us.belimo.com. For our next webinar, it is scheduled on the 31st of August, and it's going to be on communicating with the Energy Valve through WebView, Data Analysis Tool, and BACnet. Once again, thank you so much, and everyone have a great day. Thanks, Rick.